Hello everyone. Analysis part 2. Further to my first part of the analysis of the tram derailment in Sarajevo, I will speak now more about track alignment. And first of all, I'm obliged to announce a couple corrections by the designations of turnouts and crossings numbers I gave in the first part. Namely, the first turnout on the tram vehicle part is the turnout number 5. And the flat groove crossing is actually the crossing DC2. So it's important to explain the vertical track alignment of the track in subject. The other turning, that's to say, curved tracks in the area of the triangle and the triangle as the whole. This triangle is located in a curve, in a convex plane, which follows the transversal slope of the right traffic lane of the street Zmaja od Bosne. This is the name of the street, and it's a longitudinal slope matching in a way the longitudinal slope of the main double track tram line. Transversal slope results with the longitudinal slope of all turning tracks within 5 and 8 promiles. Track parts as such have to be incorporated in this convex plane without vertical breaks. That's to say, without vertical curvatures. Construction parts, 2 turnouts of 12 meters each, 1 crossing of about 9 meters, a second crossing of about 13 to 14 meters, and one track plate of about 15 meters are usually delivered, and also in this case were delivered as a single rigid welded structures, shaped at the ends to the 60 R1 groove rail profile to enable their mutual welding by using aluminothermic welding, a welding procedure which was required in the specific case. And about that, I'm going to speak by some of the upcoming announcements, more in detail. Linking these construction parts together enables, in a way, us to play with them, but just a bit, particularly in this 15-meter zone of the let's say normal rail profile 60 R1. But breaking points between individual structures remain. More or less they remain fixed. So at the end and we always have more, we can always speak more about some kind of polygonal than the curved shape of the tracks. Anyway, vertical longitudinal section breaks in turnouts and crossing zones, meaning the changes of neighboring slopes bigger than 2 promiles according to railway systems E, and up to 3 promiles by the most of S systems are not allowed. We all know, we are aware of that. If the breaks are unavoidable, they have to be located at the maximal possible distance from turnouts and crossings. I wouldn't say from them, from their beginnings, but from these critical zones at least. And with possible, of course, limitations, speed limits to the maximal, but really maximal 10 kilometers per hour. In this specific case, the development of the longitudinal slope from the tram stop area towards the railway station up to the Fatal Technical School stop must not be overlooked. All 4 tracks actually in the intersection area are in, let's say, uphill, and we're looking from the direction of the railway station towards the technical school. The main tracks. This is the result of previously mentioned convex plane in which the whole triangle is located, and all these tracks have different how to say longitudinal slopes, and they changes locations. Basically, the track alignment is 10 times, we know 10 times more sensitive, let's say sensitive than the road one. What is the percentage by roads? It's a promille by the track, and what is, for example, centimeter by the road is millimeter by the track, and so on and so on. I really do not underestimate the roads comparing to the tracks, but railway infrastructure is really much more sensitive. Road and track geometry have to be perfectly adjusted to each other, matched to avoid dynamic impacts of particularly of the road traffic to the sensitive track infrastructure. However, problems occur when we have to how to say, to match the existing road infrastructure with the new tram infrastructure. At intersection in subject, but not only there, also by many other places, locations in the city of Sarajevo. I'm sure also in your cities, it's almost never possible to adjust to match exactly the tram alignment and make this appropriately give appropriate advantage to this as it deserves. So by the preparation of conceptual designs, as during the main and detailed design processes, is always very difficult, rather difficult to have to find a compromise between that. Longitudinal slope of 5 to 88 promiles for tram traffic is not so small to be underestimated in the context of the necessary moving power and subsequently the velocity, the speed. First of all, the fastest possible start. Of course, the safe start, and that's to say also acceleration, combined with the extreme horizontal alignment parameters, as well as already described numerous of critical zones in the first part of my analysis. Situation becomes much more complex, and so the appearance of so-called parasite vehicle movements becomes absolutely unavoidable, and even by perfect track and vehicle measures and the dimensions and speed maintaining within recommended limits. It's also to emphasize that the right track, also the left one, looking from the direction of the railway station, has the slope of about 6.75 promiles towards the technical school uphill. This is a normal natural slope. Downhill. This is the normal downhill. This is the normal natural slope, followed also by a stream Sušica. This is the name of the stream, being almost at the whole length from rather close under the left track, crossing the whole intersection also zone, continuing in the next almost 500 meters up to the Miljacka River, the river Miljacka in Sarajevo. Just before the pedestrian crossing and the turnout number 5, there is a concave curve, which with a vertical curve radius of 580 meters, which is result of this slope downhill and then uphill slope through the tracks of the triangle itself. A combination of horizontal and vertical alignment in the larger technical school intersection, as you see, is of the foremost and pivotal importance for the flankway track analysis, and must be considered not only by the analysis of this derailment, but also for the further analyses which are necessary over all double track, triangle tracks, and obviously at all potentially critical locations of the existing tram infrastructure, including also those ones which are under reconstruction right now, or the new construction right now, and also have to be considered also during the future design phases. It's well known that the centrifugal force, which tends to push out a certain object from its curved moving part, is in function of, first of all, of the speed, since it's increased with the square of it. Further, the object mass and the part curvature size. that what gives resistance is first of all the gravity, but also the friction of the contact within the moving surfaces. In this specific case, the resistance at the contact flank parts with the rails and even the asphalt pavement gives this resistance. The gravity weight point plays a big role as well, and the resultant of the centrifugal force, lateral force, and gravity vertical forces location is also very important with regard to the derailment resistance part. Theoretical speed by which the tram vehicle in subject starts to tip by passing one curve like this one of 25 meters, but with continuous rails or 60R1 type. I tried to calculate very simply by balancing the between the overturning moment and stabilizing moment, if I can say that like that in English language. Anticipating the weight gravity point of the empty vehicle at the height of the 1.15 meters, I took actually the average distance from 0.8 and 1.5 by modern vehicles, and 0.8 is the minimum one. And I also took the 0.72 meters, the distance between the axis of the track as the important dimension. And making a very simple analysis, I get I think I get if I remember well, I get the maximum speed of about above about 40, I think 49.02, something like this, kilometer per hour by when the tram starts to tip the vehicle starts to tip. Video records for sure are definitely useful, but the determination of the real vehicle speed at the rollover start point, but by the objects like tram vehicles, the element of the tram infrastructure have to be considered, as I described in the first part of the analysis. Further, the combinations of the track alignments have to be checked minimum at the lanes matching the vehicle's length. Also, the position and the general vehicle condition, thus the radius and all relevant dimensions of the wheels, all relevant dimensions of all flanks, conditions of every single bogie in the context of a load and a real elastic vertical, particularly lateral deformations of all wheels, of all wheel pairs, or all bogies as a whole. Dear all, you can expect soon the next part of my analysis, or hopefully also note the last one, which should contain also some graphical presentations for the purpose, first of all, of the simplest possible explanation of this scientific category to prevent the next accidents, which are absolutely unavoidable if appropriate experiences are not considered and urgent measures not taken or moved. At the end, I must state that I see also some possible new derailment zones. I see this, for example, at the exits from the roundabouts of 25 meters. Roundabout at Jaric, for example. I will tell you something. One story what happened to me. A couple of months ago, I was in the rear vehicle part of a new modern Tango Stadler tram and moved from the standstill in the roundabout area with curve of 35 meters. Since it was necessary to stop, it wasn't necessary to stop at the tram stop, which is just behind, because the front vehicle took all passengers. The all passengers also then it was empty. The driver gave the full power to the vehicle, which was still completely inside the curve of 25 meters. On the straight part along the tram stop, the vehicle already get most probably the speed of 40 kilometers per hour. I don't know exactly, but I remember that in the end part of or the vehicle we had, we had so strong forces, lateral forces, that it was really, I can say unpleasant, very unpleasant. Most probably the driver, of course, the driver did do it intentionally, but definitely it seems that some drivers also not aware of the giving power on the front bogie. They are in the same time giving power on the all four of them, and very strong ones. So it's not always to speak and to speak. Let's say things about the old vehicles. The new vehicles can also derail, and also in the sum of the upcoming announcements, I will be free also to speak a little bit about the derailment in Milan, in Italy. Even I do not have enough information about it. So much for this new second announcement, and see you again. Have a nice time. Szedjenek, yours faithfully.